Hello everyone and welcome back to Clear Creek Solutions hydrology education videos. In this video we're going to discuss the development of the K-LIDM software for low impact development design and analysis. Recently Clear Creek Solutions, in conjunction with HEC Korea, a Korean hydrology firm, released this version known as K-LIDM, which is a new low impact development model and hydrology model for the region of South Korea. We recently did a presentation on this at a Yosu conference in South Korea, and now I'm going to go over our presentation here and give an introduction to the software. So a quick introduction to Clear Creek Solutions and HEC Korea. So as you know, Clear Creek Solutions provides a complete range of hydrologic, stormwater modeling, and consulting services. We specialize in continuous simulation and hydraulic modeling. HEC Korea, which is Hydrology Engineering and Consulting Center of Korea, is a professional engineering consulting firm established in 2009 that specializes in technologies of water resources, hydrologic planning, design, research, and development. And HEC Korea has developed many software packages for flood analysis, control, and LID, and worked with Clear Creek Solutions to develop this hydrologic model based off the wwhm 2025 for the region of Korea. Now let's talk about K-LIDM. It is based off the widely used wwhm 2012 software, which is required for use in Western Washington for all hydrologic design. And the model was adapted for the Republic of Korea with specific LID features added for design in the region. And instead of the USA counties and regions, historic rainfall data from local gauges in South Korea is used for facility design. So you can see the similarities there on the top right of wwhm 2012 and the K-LIDM. Very similar, but some changes that will fit the region better in terms of the software. So let's talk a little bit about hydrologic design in Korea. So the K-LIDM will help stormwater designers in the Republic of Korea to solve hydraulic and hydrologic problems with detailed solutions. So first big issue is water management, tracking all aspects of the water cycle and help maintain water supply management. And in relation to design standards, the K-LIDM helps engineers design facilities to meet local standards and requirements, and design customizability allows stormwater designers to mold facilities to any project's needs. In terms of water quality, by targeting erosive flows and using LID facilities, pollutants can be removed from runoff stormwater and be treated on site. Another big concern is flood control measures. Facilities can be designed to prevent excess runoff and release rates. This will prevent future flooding during extreme events. So let's talk about the engine of K-LIDM. So K-LIDM has many ways to conduct hydrologic analysis and design. Primarily, there's the map climate data similar to wwhm 2012, which allows for the use of the hourly historic rainfall for a continuous simulation run. Then there's the design rainfall section, which allows for the use of single event methodologies for facility design, not included in wwhm 2012. Then there's user input, which can be used for custom short-term and long-term simulation runs. So what exactly is continuous simulation if you don't know yet? Well, in continuous simulation, runoff frequency is statistically calculated from the long-term hourly simulated runoff data in K-LIDM. Antecedent soil moisture conditions are calculated and changed every single time step. And rainfall events are from the measured historical record. Storm shape and rainfall distribution are from the measured historical record as well. It models all the components of the entire hydrologic cycle and multiple year hourly historic rainfall used to generate multi-year hourly runoff data. So what exactly can K-LIDM achieve? Well, the K-LIDM can perform facility design of trapezoidal ponds and detention facilities and output hydrograph results. Then runoff information can be generated based on historical rainfall data, allowing for detailed analysis. Then this allows for the generation of detailed hydrographs, which can be used for further analysis or submission to jurisdictions. So you can see there about a basin facility going to a trapezoidal pond facility, very similar to wwhm 2025, but customized for the region of Korea. So K-LIDM has an auto-sizing feature that allows facilities to be automatically sized to properly infiltrate all the runoff from a project site. So note how the trapezoidal pond is set to the size the pond to infiltrate 100% of the targeted flow down there on the right. The final facility dimensions will be reflected after the auto-sizing feature. K-LIDM has ponds, vaults, infiltration basins, sand filters, and vegetated swales included as elements in the software. Let's talk about low-impact design tools. K-LIDM comes with an array of LID elements that allows designers to integrate green designs directly into their projects. The low-impact design elements have been shown to mitigate stormwater and treat runoff on-site as opposed to downstream. These elements include porous pavement, bioretention facilities, vegetated swales, and much more. and use of these elements for flow mitigation, duration matching, or infiltration, or water quality filtration. You can see all the LID connection elements down there in the bottom right, including porous pavement, bioretention, green roof, rainwater harvesting, vegetative filter strip, in-ground planter box, and many, many more. So let's talk about the map climate data. K-LIDM includes 20 plus years of historic rainfall and evaporation data that allows for continuous simulation analysis. This data is based on real measured information from rain gauges. And K-LIDM can generate runoff from design rainfall events for facility and LID design. The return period and time period can be customized. And users may import custom short-term and long-term rainfall data for project-specific model runs and facility design. K-LIDM users can select map locations anywhere in the Republic of Korea, with many regions containing multiple high-quality rain gauge data for specific project needs. So let's talk about the modeling process. First, we select the location for your project using the map option. Korean municipalities and regions are available for use with rain gauge data. Then we set up the pre-developed and mitigated project area using the NRCS land use area types. This will determine the runoff generated for your project. Then select your LID or mitigation facility for the project. Connect the elements to generate hydrograph data or meet a flow duration standard. So you can see here, 1, we select our project location on the map. You can see the map climate data. The observatory selected was Seoul. 2, we add our land use basin data using the NRCS soil types. 3, we add our detention facility. You can see it's a bioretention LID facility has been selected. Then 4, we generate our results. So we click on the map screen, we selected Seoul as the city, location, and clicked on the map. Then to select the storm type, map climate will be utilized in this case, and information can be seen in the map event window. And note, a 1-hour time step will be used for continuous simulation rainfall data. In the pre-developed scenario, we added 5 acres of C, till forest flat soil, and then we clicked the Run Scenario button. In the mitigate scenario, we added 5 acres of roads or impervious area, flat soil, and added the trapezoidal pond element for modeling. Then we connected the trapezoidal pond element to the point of compliance in the mitigate scenario. We enabled infiltration to size the facility to meet 100% infiltration requirements, meaning we're infiltrating all the runoff from the project site. We selected 10 millimeters per hour infiltration rate as the rate to enter. Then we sized the infiltration facility to meet the 100% target, infiltrating all the water. After that, we can utilize the analysis features. We can create hydrographs of any K-LIDM project, including the 2, 5, 10, and 30-year events for volume, peaks, and average. Then we can save those graphs for further reference. We can determine flood frequency results with the 20+ year rainfall record for determining peak flows and stages in your mitigation facility. We can create a report, an automated report, outlining your K-LIDM project, including location, land use area, modeling methodology, and facility design details. Then we import SWMM features into your hydrology project for ease of running hydraulic elements with K-LIDM hydrographs. So that's an overview of the K-LIDM. All the information was pulled from the K-LIDM user's manual. If you want to learn more, there's a link in the description below telling you more about the K-LIDM software. But we thank you so much for watching, and if you have any questions, leave it in a comment down below. Thank you so much for watching. Anyways, we will see you guys next time.